Hi class, in this lesson we're going to take a look at statements, connectives, and quantifiers. And we're going to be talking a lot about logic, and logic is including truth statements. Here specifically, a statement is defined in logic as a declarative sentence that is either true or false. And so we're going to be talking about statements and representing them with P, Q, or R, or any other letter. So, for example here, we've got a statement, AIDS is the leading killer of women. So it's just a statement. It can be true, it could be false, it doesn't matter. If you eat less and exercise more, you will lose weight. This is a statement. In the last 10 years, we have reduced by 25% the amount of greenhouse gases in the atmosphere that produce global warming. These are just statements again. They can be true or false, and what we need to take a look at then in contrast these is what it would look like to not have a statement. This is not a statement. Come here. If you just say the phrase come here, that's not a statement. It may have a sentence because it has a period, but come here is not a statement. So when did the dinosaurs become extinct? It's a question. It's not a declarative sentence. It's not an actual statement. And then here's a weird one. This statement is false. Now this one is weird because it seems that it would be a actual statement because it sounds a lot like a statement, but it's actually a paradox, and that's because this statement can be neither true nor false, and so we assume that the sentence, if we assume that it's true, then we have to conclude that it's false. I know that's kind of weird. And then if we assume that this is a false statement, then we're actually concluding that it's true. So it's a paradox, and it doesn't actually work as statements. So it's a declarative statement that is either true or false. It can be called a statement. And there's a difference between simple statements and compound statements. And compound statements combine several ideas together. And we use connectives and things like a negation, a conjunction, a disjunction, conditional or biconditional statements. So let's talk about these. Now, what we're going to be using is this symbol here, this the symbol that you can actually find on your keyboard. If you push Shift and then right the button above the tab button, you'll actually see that. And what we're looking for here, what we're looking at, is that these statements, you can negate them. The high definition screen is included in the price of your MacBook. So if we say this is P is this statement, then what we do is we want to negate that. So in other words, we want to have the not P. So this means not P. Exactly the opposite of what P was. So what that would mean for us is the high definition screen is not included in the price of your MacBook. Okay, so that would look like this. So again, not P is what we're looking at. Sorry, and we write this symbolically as I did above. And so let's have another statement. B, the blue whale is the largest living creature. Okay, well, that's obviously true as far as we know. But if we say not B, then we were wanting to say the blue whale is not the largest living creature. And again, it doesn't matter if we're actually making a true or false statement right now. This is the actual negation of that sentence. Okay? So, blue whale is not the largest living creature. Again, a conjunction. Conjunction expresses the idea of and. We use the symbol, this up arrow looking thing, and there's actually, looks like that on your calculator. If you push Shift 6, you will see that symbol on your keyboard to represent a conjunction. So we're going to consider these following statements. We've got P is a tenant pays utilities, and then statement D is that a $150 deposit is required. So we're going to express the statement, it is not true that the tenant pays utilities and a $150 deposit is required symbolically. So it is not true that this happens. So what that means is, in the end, I want to say that this is not true. Okay? So I want to say this part first. The tenant pays utilities and a $150 deposit is required. So I'm going to say this is P. I need P. And I do the little up arrow thing. Looks kind of like an A, doesn't it? And a $50 deposit is required. So what we want to do is negate that. It is not true. So I say it this way. So this means the inside says the tenant pays utilities and $150 deposit is required. And this means that statement above is not true. Okay. Now, let me actually show it here. So that's exactly what I just wrote a second ago. Now we're going to write the statement not P and not D in English. So what that means is I'm going to take this statement here and negate it. In other words, say the tenant does not pay utilities, and then and $150 deposit is not required. So that looks like this in full English. Oops, sorry. The tenant does not pay utilities and $150 deposit is not required. So you're negating each statement and then putting an and in the middle. So here's our and symbol. Apparently I can't see that. Here we go. So this is our and that matches up right here. Okay. So this is not P, and there's our not, and then not D is right there. Okay. So we've got order, and order matters, and we kind of noticed that on those previous statements that we were just looking at. The difference in form of these two here, we've got the use of our symbolic language here. I should probably use a different color so it actually shows up. But notice we've got the inside here needs to be done first. It's saying the P and D, and then whatever you do with that, take the negation of it. And this one's saying you take the negation first, and then use the and. And so it's kind of like PEMDAS order of operations. So be careful here because these statements sound familiar, but of course they do not say the same thing. And changing the order of logical operations changes the meaning of a statement. So let's see how this plays out. So here we've got disjunctions. Disjunction conveys the idea of or. So a disjunction is or. Notice before it was and it looked like an A. Here we've got or is a V. So and was something that looks like that, and then this is or. Here is a V. And that represents our disjunction. So consider the following statements. H, we will build more hybrid cars. F, we will use more foreign oil. So we're going to try to write this symbolically. We will not build more hybrid cars. Or, so let's go ahead and break this down. We will not do this statement. So that means I'm going to negate H. Or, so I do the V. So that means or. We will use more foreign oil. Notice this statement did not get negated, so I'm going to take this F and put it right here, F. So that is not H, so not H or F. Okay, so let me actually have it put in print for you so it's a little bit more clear, not my actual scribble. So not H or F. And then we're going to write the symbolic form of this statement in English. I'm going to read it for you, and then I'm going to have it typed. So this is saying I'm going to negate this statement. So we need to say this after we're saying the opposite of this. In other words, we're not doing what's happening inside. So what we're saying is we will build more hybrid cars, or we will use more foreign oil, and then we're not doing that. So here's how that actually works out in a statement. Translating, it's saying it's not true that, that's what this part right here is saying, it's not true that this is going to happen. We will build more hybrid cars, or we will use more foreign oil, and so it's not true that that's going to happen. That's what the symbolic form turns into in English. Okay, now we've got conditionals. Conditionals express the notation of if and then. We use the arrow to represent a conditional. Suppose that P represents the Phillies win the World Series, and K represents Kiefer will win an Emmy. So we would read the statement P arrow Q as if the Phillies win the World Series, then Kiefer will win an Emmy. So again, we're taking the P as this first statement, the Phillies will win the series. This says then, it's like a comma then, K, Kiefer will win an Emmy. And we would use the statement, we would write the statement, if it actually comes up, if the Phillies do not win the World Series, then Kiefer will not win an Emmy. Exactly the opposite. So we're looking at here, the Phillies do not win the series. So we're taking this statement here and we're negating it. So we got not P. Then, notice the then here, Kiefer will not win an Emmy. So that means I'm negating that. So I say not P, then not K. So here we end up having some biconditionals. So that means if and only if. So it goes back and forth. Now on this one, we do these a lot in math, if and only if something is true. So it's got a double meaning, and so it's a double arrow. So we've got write each biconditional statement in symbolic form. So the polygon has three sides, if and only if it is a triangle. So the if and only if gets this arrow both ways, and then the polygon has three sides. So let's call polygon P, and let's call triangle T. So if it is a triangle, we'll call T, and a polygon has three sides is statement P. So that means polygon, if and only if it is a triangle. So this can be read forwards and backwards. What that means is that we've got a triangle if it has three sides. So it goes, you can read it forward and backwards. Okay, and the actual way that this is typed up looks like this. So a polygon has three sides, and T, like I said, polygon is a triangle, P, arrow, T. Blu-ray disc can be returned if and only if the seal is not broken. So we just got to call the Blu-ray disc something, call it B. So Blu-ray disc can be returned if and only if the seal is not broken. So if and only if, it's got the arrow both ways. So Blu-ray disc can be returned if and only if the seal is not broken. So in other words, if the seal is not broken, then the Blu-ray disc can be returned. Not broken. I'm sorry, I forgot. Whoops, I forgot one part of that. I was calling B this whole term, and the key word I forgot there was not. So we got to put a little not symbol right there. So notice the answer that is down here is a little bit different than what I had just wrote before. So this should have actually been the Blu-ray disc is returned if and only if, I call this S, not B, so I say S, so not S. Or here, R, if you name the Blu-ray disc R, if and only if the seal is not broken. And again, the word not should be this little symbol right there. Okay. Now, universal quantifiers is how we're going to finish this section. Are words such as all and every, and they really make our statements very broad. Now, universal qualifiers, all citizens over the age of 18 have a right to vote, every triangle, each NASCAR driver. So when you're talking about universal qualifiers, it's making a very large, broad statement, things that you don't usually want to use in conversation to get somebody frustrated, probably. Here we go. Existential qualifiers are words such as some, there exists, and there is at least one. States that there are one or more objects that satisfy a given property. So some drivers qualify for reduced insurance rate. There is a number whose square is 25. There exists a bird that cannot fly. So we're saying that there's one or more that fit that description. So negating sentences with qualifiers. So on these statements, we're trying to negate them. We're trying to have the symbol with the symbol that means not this. So here we've got all customers will get a free dessert. So we want to say not all customers will get a free dessert. And what that looks like is this right here. Not all customers will get a free dessert. That means at least one is not going to get a free dessert. So at least one customer will not get a free dessert. It's another way that we can say it. So what we're looking at here is that not all can be rewritten positively. At least one will not get one. So at least one customer will not get a free dessert, or not all. I hope you see the connection here between these two. So not all matches up with at least one will get it. Because not all won't, not all will get a free dessert, or at least one will not get it. Okay, and then some tablet computers have a 2-year warranty, so we're going to have a very similar statement here, which is saying it is not true that some tablet computers have a 2-year warranty. Because this statement has a form not some have, we can rewrite it as none have. So in English we can say no tablet computers have a 2-year warranty. So some tablet computers have a 2-year warranty, and it is not true that some have a 2-year warranty. Now the difference here is that when it says some have a 2-year warranty, and then we're negating that, it's excluding that some could have a 2-year warranty. That means if we're saying not true here, that some have a 2-year warranty, the only thing left over is that the some that did, there aren't those, so that means there are none at all. No tablet computers have a 2-year warranty. So that's the end of this lesson. I hope that that was helpful. If you have any questions for this section, please let me know. Email me through the Ask My Instructor feature of the lab.